Part 3. I'm given that two sides of a triangle have the length of 9 and 20, and I want to find the measure of the angle between the sides if the area of the triangle is 45. I sketch out my triangle, making the longest side the base of the triangle. The red line represents the third side, and I can label the sides I know, 9, the base 20. I can drop a perpendicular to the x-axis. I'll label that altitude y, and I'll label the angle between 9 and 20 theta. In looking at the triangle with that right triangle made by the perpendicular, I can say that the sine of theta is equal to the opposite side y over the hypotenuse 9. I'm going to use this value and substitute it into my area equation a little later on. I know that the area of a triangle is equal to half the base times the height. And in the triangle that I'm using, its area is 45, 1/2, the base is 20, and the height is y. I can go back to my sine equation, multiply the 9 over to the other side, and get y is equal to 9 sine theta. Going back to the area equation, I can clear the fraction by multiplying both sides by 2 and get 90 equals 20 times y, and I can replace y with 9 sine theta. At this point, I can multiply the 20 times the 9 and get 180 sine theta. Divide both sides by 180. 90 over 180 is 1/2, equals the sine of theta. And then theta is equal to 30 degrees. In question 7, I'm given that the sine of theta equals 3 over 5, and that theta lies in the first quadrant. I'm trying to find the sine of 2 theta. As always, I'll sketch my triangle. Value theta, I drop the perpendicular. I know that the opposite side is 3, the hypotenuse is 5, and I can find the adjacent side x by using the Pythagorean theorem or by remembering the special Pythagorean triple 3, 4, 5. Using Pythagorean theorem, x squared plus 3 squared equals 5 squared. I get 25 minus 9 is 16, and x again is 4. I then take the sine of 2 theta and expand it to 2 sine theta cosine theta. I know that the sine of theta is equal to 3/5, so I can replace it, and I just have to find out what the cosine of theta equals. Going back to my triangle, the cosine theta is the adjacent side 4 over 5, so I replace that fraction for cosine of theta, multiply everything together, and get 24 over 25 for the sine of 2 theta. In question 8, I'm trying to find which of the 4 equations has a solution. One of the things to remember is that the trig ratios, sine and cosine, always have to have a value of 1 or less, or in other words, in the fraction, the denominator, which represents the hypotenuse, always has to be the bigger number. In looking at my 4 answers, answer B has a denominator of 3 and a numerator of 2, and it's the only fraction that is less than 1 and whose denominator